Hello everyone, welcome you back for the programming session. Now here in this model 1, the model 1 shows the component with a dimension of 85 by 85, and here in this 85 by 85 also there are three, what we can say, the fillet radius as there. The fillet radius in the sense, the three inside fillet radius and one is the outer fillet radius are been on the component. Now for this, to fabricate the component, we will select a billet size of x is of 100 and y is of 100 and z is of 10. Now first what we will do is, now instead of going directly into the program, first what we will do the coordinate systems, or it may be the coordinate points with respect to the each and every corners, and then afterwards the same dimensions if we implement into the program, that will be a easiest method to make that what we can say coordinates. What we will do is we'll make it into a tabular column. The first corner which is nothing but something at the bottommost corner where the x dimension is of 20 and as well as the y dimension is of 10. And if the same thing, if it is moved to the left side, the left side corner point where the x dimension is of 65 and the y dimension is of 10. The same thing, if he moves with respect to the other corner after the fillet radius, that corner is nothing but, as the x dimension is of 75 and the y dimension is of 20. The same thing, if we move it up, the starting point of the arc where the x dimension is of 75 and the y dimension is of 65, and after the contour, the another point which is towards the right side, if it's coming it, that point is nothing but x dimension is of 65 and the y dimension is of 75. And the same way, as we are moving towards the left side, the first corner what we are getting, the x dimension which is of 20 mm and the y dimension is of 75 mm. After the fillet radius where the x dimension is of 10 and the y dimension is of 65, and if it comes down, which is nothing but the corner point, or which is slightly above the starting point where x dimension is of 10 and the y dimension is of 20. See, these points, once first if we locate it and if it is identified, means the programming it will be very easy. Now even in the programming also, there are 3 to 4 different parameters we are referring it. The first parameter is nothing but n10, n20, n30, n40, like that. It's nothing but a line number. The second one is nothing but the G codes. The third point is with respect to the dimensioning. Either it may be the x, y, z, or it may be x, y, r. R is nothing but the radius compensation. Along with this radius compensation, in some cases f also we are giving it. F is nothing but the feed, or even in some cases we are using the s compensation also. S is nothing but the speed of the spindle. See, that depends upon the type of the line and where we are writing it. In some cases, in some lines we are using the T also. T representing the type of the tool what we are using it. Now what we will do is we will try to write the program. The first line n10 is G21, G90 and G24. G21 is the dimensions with respect to the mm, and G90 is nothing but the absolute programming, normally what we are using it, and G94 is nothing but feed mm per minute. The second line n20, G28, x0, y0, z0, which is nothing but the origin. The third line n30, m06 and as well as the t01. T01 is the type of the tool what we are used for the selection for the milling process. N40, m03 and s1500. M03 refers the spindle speed, or it may be the spindle which is moving in the forward direction. M04 is for the reverse direction. Okay, as you are moving it from the left to right, we have to use the M03 and with a speed of 1500. G40 is for the tool nose radius compensation cancel. See, tool nose radius compensation. It is cancelled means we are not selecting either. It may be to the left side or it may be to the right side. It is moving exactly on the what we can say the center of the tool itself. For that reason, we are considered it as the G40. Okay. G40. Next, N6 here, N, or it may be in the sixth line, G00, X20, Y10 and Z2. The programming referring point. See, this is the starting point of the program where which is represented by the point 1, where the X dimension is of 20 and the Y dimension is of 10. N70, G00, X20 and as well as the Y10. Okay, then N80, G01, Z of -5 and F is equal to 30. Z -5 refers to that we are giving a depth of -5, and as you know that size of the entire billet is of 10 mm. The line number N90, G01, X is equal to 65, Y is equal to 10 and a feed of 30 only. Next, N100, G02 and X75, Y20, R of 10. R of 10 is nothing but the radius compensation, normally what we are giving it, and the feed rate is of 25. See, as the tool is moving with radially, the speed it should be of a lesser one, and it is moving in the clockwise direction. For that reason, we are using G02 as the code. In the line N110, G01, which is nothing but again it is moving in the forward motion, and it's in the X of 75 and Y of 65, F of 30. The feed rate it is remains common and as well as a constant. N120 in the line, X is G of 03, X of 65 and Y of 75, R10 and as well as F, it can be made it as the 25 or it may be of 30. See, but here in this slide we are considered it as a F of 30, but in the previous line, somewhere in the line where the N100, where the feed is of 25 we are considered. Why means here in this case the contour it is moving radially outward movement, there is no problem, and even the feed if it remains constant also nothing to worry. But if it is moving radially inside, then the speed or it may be the feed or it may be what we can say the depth of cut, it should be a very minimum. The N130, G01, X of 20 and Y of 75, F of 30, and N140, G02, X of 10, Y of 65, R of 10, and even here also the feed rate it can be changed to F of 25 itself, and even it is moving in the clockwise direction. In the previous case it is moving in the counterclockwise direction, but here in this case it is moving in the clockwise direction. In the line 150, G01, X of 10, Y of 20 and F feed of 30. In the line N160, G02, X of 20, Y of 10 and R of 10 and F of 30. In the line N170, G000 and Z2, Z2 where it is moving up, and N80 G40, the two nose radius compensation cancel, and in the case of the N190 line, G28 x0 y0, which is nothing but return to the home point or the fixed point, and G310 M05 the spindle stop, and as well as N320 M30 where the program end and as well as rewinded. See, this is a program which is used to get the component. Now here in this case, the feed rate and as well as the what we can say the spindle speed, it can be varied depending upon the type of the contour what we are fabricating or what we are manufacturing. If we are going for the inside radius or it may be internal radius, then the feed rate it can be given as a smaller one. Once if the same thing, if it is moving outwards, or it may be outside radius compensation if we are giving it, or the outer what we can say the fillet radius if you are cutting means, then the feed rate it can be of the same as that of the normal which is in the straight line motion.